Hey guys, this is going to be a video covering the Unit 2 review for the upcoming test. It was pretty well requested that I do one of these this time around for this test. I guess you guys weren't too big of a fan of what I did last time, which is fair. But that being said, there are questions that for this review that I'm pulling just from the homework, maybe kind of ones from the notes, but this is kind of me meeting you in the middle, so we'll see how we go. Okay, so question 1. The density of bacteria population in a circulate petri dish at distance r centimeters from the center of the dish is given by an increasing differentiable function f, where f of r is measured in milligrams per square meter. Values of f of r for select values of r are given in the table. Use the data in the table to estimate f prime of 2.25 using correct units to interpret the meaning of the answer in the context of the problem. I swear I went back and I corrected this, but it looks like I didn't, but whatever. Okay, let's see. So we're going to estimate f prime of 2.25 using values in the table. So here's the table given here. So f prime of 2.25 means the derivative at 2.25. And since all we have are values from this table, we are going to use the average rate of change over this interval right here to estimate my derivative. So we'll say that this is about equivalent to 10 minus 6 over 2.5 minus 2, and that's equivalent to 4 over 1/2, which is equivalent to 8. And the units here would be, so the rate of change here would be f of r over r. Since that's what the average rate of change is, it's the rate of change of one variable with respect to another. So this f of r is defined as milligrams per square centimeter. And if I divide that, put that over here, I can just say this right here. It's equal to centimeters squared per centimeter. And you can leave your answer just like that. I know it's kind of weird, and you might just think, well, I'm just going to do centimeter squared divided by centimeter, which is centimeter, which I wouldn't really do. I would just leave it like this right here. So we're saying 8 centimeters squared for every centimeter. That's the approximated rate of change. So how would I answer that? So interpret the meaning of your answer in the context of the problem. So I would say really you just have to look at the context of the problem and just put it all together. But you can say the density of bacteria in the petri dish at we'll say 2.25 centimeters from the center is increasing at a rate of 8 square centimeters for every centimeter. Centimeter. And that should be good. The density of bacteria in the petri dish at 2.25 centimeters from the center. So whenever at a measure of 2.25 centimeters from the center, which would be the radius, right? When you're at that distance from the center, the bacteria is increasing at a rate of 8 centimeters squared for every centimeter. Yeah, I think that sounds pretty good right there. Okay. Let's keep going. Question 2. An equation for the line tangent to the an equation for the line tangent to the graph of a differentiable function f at x equals 3 is, so this is a tangent line to the graph of f at x equals 3. Which of the following statements is true? So just one thing that you need to know is that if this line right here is tangent to the graph of f, then it intersects at the x value of 3. So that means this function right here, the tangent line at x equals 3, is going to be equal to the function at x equals 3. In other words, they share the same coordinate point. Okay? And also at this point, they share the same slope. And so right here, I can say that f of 3 is also going to be equal to 4 times by 3 plus 6. Now, this right here is not the function. That's not the function. This is the tangent line. But I do know that f of 3 is going to be the same value of the tangent line at x equals 3, so I can do this right here. And that's going to be equal to 12 plus 6, which is going to be equal to 18. So I know that f of 3 is going to be 18. I can already just say that this is going to be false right here, because I don't have any way to find f of 0 equals 6. I can't plug in 0 in here because this is the tangent line, not the function. The only reason I could plug 3 into the tangent line is because I know that they're going to be the same at x equals 3. Another thing, since like I said earlier, they are going to share the same slope, so f prime of 3 has to be equal to the slope of the tangent line. And that's 4. So f prime of 3 is going to be equal to 4. So this is also going to be true. Alright, for number 3, values of a differentiable function f and its derivative at x equals 2 are f of 2 equals negative 3 and f prime of 2 equals 1. If a of x is equal to 2f of x minus x, find an equation of the line tangent to y equals a of x at x equals 2. So, I'm writing an equation of a tangent line. That's y minus y1 equal to m times by x minus x1. So this line right here is going to be tangent to the graph of a of x, not f of x. It's going to be tangent to the graph of a of x. If it were tangent to the graph of f of x, this would be a much easier problem, since I know that f of 2 is equal to negative 3. We already have slope, or we already have a point here, and then here we would have the slope. So if it were asking for the tangent line to f at x equals 2, we could just plug in 1 right here. We could plug in negative 3 right here, and we could plug in 2 right there. But we're doing this for a of x. So we know that it's happening at x equals 2, so I need to find a of 2, and that will give me the y value. So that's going to be 2 times by f of 2 minus 2. That's 2 times by, and f of 2 is negative 3. So this is going to be negative 6 minus 2, which is going to be negative 8. Now that I have the y coordinate, I have the x coordinate, now I need the slope. So m is going to be equal to a prime of 2. And that's going to be equal to, well, first of all, I need a prime of x. So a prime of x is going to be equal to 2 f prime of x minus 1, since the derivative of x is 1. And then a prime of 2 is going to be 2 f prime of 2 minus 1, which is 2 times by f prime of 2 is 1 minus 1. So that's going to be 2 minus 1, which is going to be 1. So this right here is going to be my slope. So my tangent line is going to be y plus 8. So that's y. And then equal to 1, because that's my slope, times by x minus 2, because that's my x coordinate. If you feel the need to put this into slope-intercept form, you can, but you can also leave it right there, and that is fine. All right, so there's my tangent line. There we go. 4. Let f be the function given by that right there of the following values of x, at which does the line tangent to the graph of f have the greatest slope. So what you're going to do here is you can use your calculator here. Don't try and take the derivative by hand. You can for these terms right here, but not for this one, since we do not know how to take the derivative of this right here. And you might think, well, the derivative of cosine is negative sine. True, but the inside of this is x squared. So this is called a composition. It's a composition of cosine of x and x squared, and we do not know how to do derivatives of compositions of functions. We only know how to do derivatives of sum and differences, quotients and products, not compositions. So I would not try and do the derivative by hand. Maybe next unit you can, but in any case, just use your calculator. So I'm gonna go to my calculator, and I'm just gonna go to math, and then go to option 8. I'm gonna type in the function. That's gonna be x to the 4th. Please let me. It's just not gonna let me do it, huh? Okay. Looks like I'm typing this in. X to the 4th plus x to the 3rd minus 3x squared. 3rd minus 3x squared minus x minus cosine of x squared. So x to the 4th plus x to the 3rd minus 3x squared minus x minus cosine of x squared. Okay. Then I'm going to go to just put that in vars 1, and then we're going to just go through those values. So at -2, it's negative 5973, negative 5973. So what was it again? I'm going to keep Desmos. So okay, negative 5.59973, something like that. Right, 793,973,973. Okay, and then I'm just gonna go back up here, copy it down, delete, and then I'm gonna do -1, do enter, 317, and then copy it back down and do 1, 1683, and that well, for 0, that's gotta just be 1 then, right? No, maybe. -1. -1. Okay, and so that's, oh my goodness, there's a typo there. Has the greatest slope, that's got to be b. That's the greatest value here. Now, if you guys don't have a calculator at home, you can go to Desmos, and then you can type in the function. Just make sure you type in the function. I mean, like, honestly, you can just do, I would do, type in f of x. You have to do this part right here. So f of x is equal to x to the 4th plus x to the 3rd minus 3x squared minus x minus cosine of x squared. Okay, and then if you want to calculate the derivative, you can just type in we're gonna do f prime of, and then you can type in, so like -2, and then it tells you what it's going to be right there. So negative 973, you can go back here, we can do at 0, it's -1, so on and so forth. So you can do that if you don't have a graphing calculator at home. Okay, so for f, let f be the function given by f of x equals the absolute value of x. Which of the following statements about f are true? So we know, I know anyways, hopefully you know, the graph of the absolute value of x, which looks like this right here, is it going to be continuous at 0? Yeah, that's true. It is going to be continuous at 0. There's no hole here, there's no jump, there's no asymptote. It is continuous. The limit from the left and the limit from the right is equal to 0, and the function is equal to 0. F is differentiable at x equals 0. That is false. There is a corner here, as slope from the left is not equal to the slope from the right. F has an absolute minimum at x equals 0. That is also true. Okay. When x equals 2e, the limit as h approaches 0. Okay, so for this one right here, it's important for the test and in general that you know what this means right here. This right here fits the definition of a derivative. The limit as h approaches 0 of f of x plus h minus f of x over h. Okay, this right here is equal to d dx of f of x. That's what that is equal to. What is the function? I mean, honestly, if there's no value being substituted in here, it's quite easy to see what f of x is. F of x is going to be the natural log of x. As long as we're not like putting in h value here, an x value in, like at x equals 2 or x equals 3 or whatever value, if we're not evaluating the derivative at any given point, it's quite easy to tell from the formula what the function is. This right here means dx of the natural log of x. That's what that means right there. And that is equal to 1 over x. So then what is this going to be at x equals 2e? It's going to be equal to 1 over 2e. There you go. Okay, let f and g be differentiable functions such that f prime of 0 equals 3, g prime of 0 equals 7. If h of x equals 3, f of x minus 2, g of x minus 5 cosine of x minus 3, what is the value of h prime of 0? So h prime of x is going to be 3 times by f prime of x minus 2 g prime of x. The derivative of 5 cosine, the derivative of cosine is negative sign. So that's going to turn that to plus 5 sine of x. And the derivative of negative 3 is 0. And we want h prime of 0, that's 3f prime of 0 minus 2g prime of 0 plus 5 sine of 0, which is 0. So h prime of 0 is going to be 3 times by f prime of 0, which is 3, minus 2g prime of 0, which is 7. This is going to be 9 minus 14, which is equal to negative 5. Let f be the function given by, okay, what is the value of f prime of 1? So let's find f prime of x. That's going to be equal to 16x to the third plus 15x squared minus 2x plus 0. And f prime of negative 1 is going to be 16 times by negative 1 cubed plus 15 times by negative 1 squared plus 2. That's going to be equal to negative 16 plus 15 plus 2, and that's going to be equal to 1. The graphs of the linear function f of x and g, oops, didn't write g of x, but whatever, are shown here. So h prime of x is equal to f prime of x plus g prime of x. So I'm just using the sum and difference rule here. Now, h prime of x, since f of x right here, you can see f of x and g of x are always linear, right? And so f prime and g prime are going to be constant. I can get those from the graphs, or I can get them from the equation. But f prime of x is always going to be 3. And g prime of x is always going to be negative 5 halves. So that's 6 over 2 minus 5 over 2, and that's going to be equal to 1/2. That's what h prime of x is going to be. Yeah. Also, you can see right here, this is a linear function, this is a linear function, so f plus g is going to be a linear function. So h of x is just going to be 3x minus 1 plus negative 5 halves x plus 2. So these are the only terms that matter. Again, whenever you add 3x and negative 5 halves x, that's going to be just negative 1/2 x. And then plus 1. So here you go. Here's the function of h of x. And then h prime of x has to be negative 1/2. Hold up. 1/2. There we go. Because that's going to be 6 over 2, right? 3 is the same thing as 6 over 2 minus 5 over 2. That's going to be just 1/2. Yeah, there you go. Okay. All right. Number 10. Let f be the function given by 2 cosine of x minus 3 e to the x. What is the value of f prime of 0? So first, let's find f prime of x. The derivative of cosine is negative sine. So negative 2 sine of x. And minus 3 e to the x, since the derivative of e to the x is e to the x. And let's do f prime of 0. That's going to be negative 2 sine of 0 minus 3 e to the 0. That is 0 minus 3, negative 3. Alright, if f of x equals 3x squared plus e squared minus the natural log of x, so let's find f prime of x. That's going to be equal to 6x plus 0. This right here is a constant. So its derivative is going to be 0. Minus 1 over x, since that's the derivative of natural log of x. And we want f prime of 2. That's going to be equal to 12 minus 1 over 2, which is equal to 24 over 2 minus 1 over 2, which is equal to 23 halves. The graphs of f and g are shown. If the function h is defined by h of x equals f of x times g of x, then h prime of 1 equals f is the function that is above, g is the function below. Okay, so let's do h prime of x. Since this is a product, we'll need the product rule. It's going to be the first times by the derivative of the second plus the derivative of the first times by the second. So h prime of 1 is going to be equal to f of 1 times by g prime of 1 plus f prime of 1 times by g of 1. F of 1, so f, this is the function f. At x equals 1, it is 3. So f of 1 is 3 times by g prime of 1. Here's the function g. G prime of 1 is going to be 0, since the slope of that line is 0 at 1. Plus f prime of 1, so we want the slope of this line, that is 1/2, times by g of 1, and g of 1 is 1. So this is going to be 0 plus 1/2, which is equal to 1/2. There we go. Alright, so for 13, g of 4, g prime of 4, let j of x equal g of x over square root of x. Find j prime of 4. So let's find j prime of x first. And it's a quotient, so we're going to use the quotient rule. That is low d high minus high d low, square the bottom, away we go. That's just going to be x if I square the bottom. Okay, and then we want j prime of 4, so that's going to be equal to, that's going to be 2. G prime of 4, whoops, g prime of 4 is 1 minus g of 4, which is 5. And then this is all going to be divided by, since it's being multiplied by a fraction, it's all going to be divided by 2. If I plug in 4 right there, that's going to be square root of 4, which is 2. So 2 times 2, that's going to be 5 over 4. All over 4. Okay, and that's equal to 8 over 4. 2 is equal to 8 over 4 minus 5 over 4, which is equal to 3 over 4, which is equal to 3 over 4 times by 1 over 4, which is equal to 3/16. Okay, for 14, if y equals cotangent of x minus secant of x, then dy dx, so dy dx, it's asking for the derivative. Derivative of cotangent is negative cosecant of x, secant squared of x, sorry, and minus secant of x, and secant, the derivative of secant of x is secant x times by tangent x. Which of the following correctly shows the derivative of cotangent of x? So, if I look, they're all the same right here. So, derivative cotangent, okay. So, all these, yep, okay. Let's check this first one right here. I know that these two are going to be wrong. It's not going to be these two because right here, this is ignoring the quotient rule. Since this is a quotient right here, you would have to use the quotient rule. I can't just take the derivative of the bottom. I would have to do the quotient rule. I can't just go ahead. There's no rule that allows me to do the derivative of the quotients, just like that, to get the derivative of this anyways. So it's up to C and D, and the only difference between these options right here are the minus and the plus. So just if you apply the quotient rule, that is low D high, they both have that, minus high D low. Square the bottom. Okay, so it has to be C. It's not going to be D because we can't have that being plus right there. So it has to be C. Okay. All right, now this right here, I'm outlining what you should know for your for the free response questions that will be on the exam. I don't have like a practice problem of them. I know you guys might be angry at that, but hey, at least I gave you guys some practice problems here. But I'll go through and tell you what I think you guys should know. So know how to find the average rate of change over an interval using a graph, table, or a formula. So the average rate of change is just y2 minus y1 over x2 minus x1. So if you're given a graph, it might just be easy to just find the slope between 2 points. If you're given a table, well, we did that like right up here with the table, so you should know how to do that. And with a formula, you just need to know how to take the equation and plug in x values and then get the y values out of them, and then just use the same formula that you did using the table. So know that. Be familiar with questions such as question 1 from 2.3 to 2.4. So 2.3, 2.4, right here. So in this problem right here, we have the slope of the secant line, which is average rate of change, and we're trying to see how many times the instantaneous rate of change, which would be slope of a tangent line. So how many times can I make a tangent line in this interval right here, and the tangent line slope will match the slope that's given here. So that's about 1, 2, 3, 4. So if you know how to do this problem, you'll be good on the problem that I'm going to have on the test, okay? Know how to write an equation for tangent lines at a given value of x. you should know how to get the y value of your point and your slope given a formula, graph, or table. So tangent line, y minus y1 equal to m times by x minus x1. So you should know how to get the y value. If the point is just not explicitly given to you, honestly, to get a tangent line, you pretty much always have to at least start with the x value. So whenever you're on the AP exam, if you're finding an equation for a tangent line, at the very least you'll have an x value, if not the point x and y. But if you have the x value, you should be able to get the y value. Now, though, you might have to use a graph to get the y value. So if you have the graph of f or something, and if you have the graph of f, then look at this x value and see where the y value is. If you're given a table, do the same thing. Look at the x value, find the y value. If you're given a formula of the function f, then plug in the x value to get the y value. And then to find m is going to be the derivative of your function. Now, sometimes what if the derivative is given to you as a graph? Then look at f prime at this x value to get the slope. So can you get all this information from a formula, graph, or table? So it's pretty easy. You just need these three things. This is usually given to you. You can plug this into the function to get y, and plug this into the derivative to get m. So that should be pretty straightforward. And again, you might be given graphs or tables. You might be given a graph of f and f prime. You might be given a table of f and f prime at this given value of x. In that case, it should be easier because you don't have to plug anything into the formula to get these values. But okay, for 18, you should be familiar with the definition of a derivative. So whenever I say that, we have two definitions of a derivative. The limit as h approaches 0 of f of x plus h minus f of x over h. I don't know why I put a parenthesis there. Don't need a parenthesis. Or, now this right here is equivalent to d dx of f of x. And then there's another one, the limit as x approaches a of f of x minus f of a over x minus a. This right here is the derivative of f of x at x equals a. And this could be interpreted as the same thing, just instead of x, you'd have an a value. So I could put a right here and a right here, and this would be at x equals a. But in any case, these are the definitions of a derivative. So if you're presented with a definition of a derivative, pretty much this is what I want you to be able to do. Given something like this right here, can you tell that this means this right here? That's what I want you to know. Okay? Know this right here, and know that this means this right here. Okay? 19, know the product rule. Pretty straightforward. If you don't know it, d dx of f of x times by g of x is equal to f prime, the first, times by the derivative of the second plus the derivative of the first times by the second. So don't just know the product rule, but know how to use it with functions, tables, graphs, formulas, so on and so forth. Okay, and then for this one right here, I just recommend that you know how to do question 10 on 10.8 through 10 right here. So that's the... Know how to do this problem right here. Okay, and if you don't know how to do this problem, I recommend looking at the video that I have for it. Now, you should be familiar, like if this information right here is given to you, you should know how to, if the information given was in the form of graph or graphs, you should still be able to know how to do that. So if you were given a graph and these were all the same, if these values were, given as a graph instead of a table. You should know how to do that too, okay? So know the product rule, how to evaluate given a graph or table, and using a calculator. So in this problem right here, you were given a function that you do not want to take the derivative by hand, because this right here is a composition. Yes, this is a product, but this is a composition, and we don't know how to take the derivative of such things yet. So, but you need to be able to use your calculator to find the derivative of each of x when needed in the problem. But the derivative of f prime of x I can just get from the table. But yeah, so know how to use the product rule to evaluate given a graph or a table, one of those two, and using your calculator. Know the quotient rule, how to evaluate given a graph or a table, so same thing. But yeah. Okay, hopefully you guys found this video helpful. Good luck in your studies. Let me know if you have any questions.